Hey, I'm Dark Steel, and welcome back to another Prepper Friday rant. This sweater, I think this is kind of funny because I realize that this sweater thing's getting a little out of hand. But but while I have other ones, my wife went out and bought me this one specifically to wear for this week's Prepper Friday. So I just thought that was hilarious and worth a mention. So anyway, off of the ridiculousness and back onto the Prepper rant. Stick around to the end of the video for the Prepper Tip of the Week. Today's subject will be on the moving magnetic North Pole and some theories that I've heard on how it could affect your Prepper plan. Besides throwing off compasses and GPS by shifting from place to place, I've heard a theory that could be a little bit more dramatic, a little bit more devastating, if it pans out to be true. So please join me in researching this. Tell me what you know. We'll have this conversation in the comments so that we can figure this out together, because this is worth looking into. And I in a few minutes on Google. I mean, I haven't really done a whole bunch of research, so I'm not claiming to be an expert on this. I am just repeating what I heard so that we can open that conversation. But I think it's worth looking into together. Okay, so essentially the theory that I've heard is every so often we are supposed to have a shift where magnetic north and magnetic south swap, where they change directions, and that we're due for it, that we're a few thousand years off, and we are it's time for this to happen. So the other day when I read in the news that magnetic north has shifted into high gear and started moving faster than it's moved in the last, I think it said like 200 years or something like that. I went, okay, is this that event? And you know, I'm not sure still. They said scientists can't explain why it would be doing this. But again, I've been waiting for this event to happen for a few years now, based on this theory that I heard. So I'm a little bit sketchy on whether or not that's the event that I'm talking about or not, but it's worth, like I said, it's worth keeping an eye on. But the theory that I heard is that during this shift, as it goes around the globe, about here, the magnetosphere shuts down temporarily while it moves, and then it comes back up again. I'm not entirely sure why this would happen, but humor me here. If it were to happen, then we'd lose the magnetosphere for a moment in time. Now, that moment in time could be months or years. I'm not sure exactly how long that would be. So what is a magnetosphere? I thought we'd go over to the computer and talk about that a little bit. Okay, so here we are at science.nasa.gov, and we are on an article titled Magnetospheres. A magnetosphere is a region around the planet dominated by the planet's magnetic field. Other planets in our solar system have magnetospheres, but Earth has the strongest one of all the rocky planets. Earth's magnetosphere is a vast comet-shaped bubble which has played a crucial role in our planet's habitability. Life on Earth initially developed and continues to be sustained under the protection of this magnetic environment. The magnetosphere shields our home planet from the solar and cosmic particle radiation, as well as erosion by the atmosphere by the solar wind, the constant flow of charged particles streaming off the sun. Earth's magnetosphere is part of a dynamic, interconnected system that responds to solar, planetary, and interstellar conditions. It is generated by the convective motion of charged molten iron below the surface of the Earth's outer core. Okay, and I'm leaving a lot of this article unread. I will put the link to it in the description of this video, so you can go read it yourself, but I just wanted to give a basic idea of what the magnetosphere is. Okay, so think of the Earth's magnetosphere as kind of a big invisible force field that protects us from cosmic radiation. Some of this cosmic radiation can happen when we have what's called a mass coronal ejection, which is where the sun kind of erupts. It has a solar flare, a solar storm, and throws energy out towards the Earth, or, you know, in different directions, but we're only concerned with what's going towards the Earth. And it can either hit directly or skid by, but when it hits this magnetosphere, it's kind of reflected off, so it doesn't quite actually affect us most often. There have been events where it actually did affect us, but for the most part, it doesn't make it through the magnetosphere, and this is what causes, from what I've heard, I am not an expert, but this is what causes the aurora borealis, the northern lights. This is just most of the time a harmless but interesting event that happens. However, as I mentioned, if the force field shuts down for a period of time before starting back up again, if a mass coronal ejection were to happen during that time, the theory states that what I've heard says that everybody in the world would look up at the skies, seeing a beautiful light show as aurora borealis just kind of spreads across our skies. The sky changed colors for a minute, and then all electronics that have a charge, so anything that's plugged in, anything that's got a battery hooked up to it, anything that is running on a charge, essentially shorts out in a burst of EMP. So the planet could change in a moment's notice. So we're talking a global shutdown of power, at very least, if it doesn't just, wipe us out altogether. But in this case, and I'm going to rain some gloom and doom on you real quick, in the case that this theory is absolutely accurate and this does come to happen, airplanes in the sky would, their instruments would fail. Same with helicopters, which an airplane could at least, coast. Helicopters just going to fall. People with pacemakers could just go into cardiac arrest and start dropping left and right. The entire world would shudder in devastation momentarily. We're not talking about just the end of Facebook and YouTube. We're talking about the death toll globally in a moment's notice would be so massive that it's inconceivable. So that would be the first one, and I don't know how to, I don't know how to protect us from that. So I'm not going to give any solutions on that one because I don't have any. But just so that you understand the severity of that situation. Okay, so I thought we would talk about why the North Pole moves, because this is actually, apparently this is a common event. This is just what it does. But the news report was on how it rapidly picked up in speed. And from my understanding is continuing to increase in speed. I don't know. I might need correction on that one. But, okay, so this is from howstuffworks.com. Okay, why does the North Pole move? The Earth has several poles, not just two. It has geographic north and south poles, which are points that mark the Earth's axis of rotation. It also has magnetic north and south poles, based on the planet's magnetic field. When you use a compass, it points to magnetic north, not to the geographic north. Earth's magnetic poles move. The magnetic North Pole moves loops of up to 50 miles, or 80 kilometers, per day. But its actual location and average of these loops is moving at around 25 miles per year. In the last 150 years, the pole has wandered a total of about 685 miles, or 1,102 kilometers. The magnetic South Pole moves in a similar fashion. The poles can also switch places. Scientists can study when this happened by examining the rocks on the ocean floor that retain traces of the field, similar to recording a magnetic tape. Last time the poles switched was about 780,000 years ago, so there you go. And it's happened about 400 times in 330 million years. Each reversal takes 1,000 years or so to complete, and it takes longer for the shift to take effect at the equator than at the poles. The field has weakened about 10% in the last 150 years. Some scientists think that it's a sign of a flip in progress. Okay, so here we go. Here's kind of backing up some of the stuff that I said. I really need to start reading this stuff before I start the video. The Earth's physical structure is behind all this magnetic shifting. The planet's inner core is made up of solid iron. Surrounding the inner core is a molten outer core. The next layer out, the mantle, is a solid but malleable like plastic. The Earth itself spins on its axis. The inner core spins as well, and it spins at a different rate than the outer core. This creates a dynamo effect, or convection and currents within the core. This is what creates the Earth's magnetic field.
it's like a giant electromagnet. Exactly how the dynamo effect changes the field isn't widely understood. Shifts in the core's rate of spin and current within the molten materials most likely affect the planet's field in the location of the poles. In other words, the poles move because the convection of the core changes. These changes might also cause the poles to switch places. Irregularities where the core and mantle meet and changes to the Earth's crust, like large earthquakes, can also change the magnetic field. Okay, that's all we got for this one, and I'll post a link to that too, so you can do a little bit better reading. There's a little bit more here, and I think there's even some links that you can click on, so it's worth checking out. Okay. We're also going to come over here, which is the potential devastating effects of coronal mass ejection. Solar flares are energetic explosions of radiation released from the surface of the sun. Coronal mass ejection, solar explosions that release extremely hot streams of plasma into space, can cause solar flares to reach the Earth's surface. Although rare, powerful solar flares have the potential to cause damaging magnetic storms on Earth. In the past, they have triggered regional blackouts. There are telltale signs of an impending solar flare, but scientists have recently discovered a new way of predicting coronal mass ejection. The answer lies in the sun. This is talking about how that happens, and again, I'm going to post a link. I'm going to try and shorten this video, so I'm not going to read all of this. I'm just going to scroll down a little bit, but I will absolutely post it so you can read it yourself. The Earth rarely experiences solar flare effects, yet they can have dramatic effects when they do occur. In 1859, a plume of magnetized plasma shot 93 million miles from the sun to the Earth in less than a day, known as the Carrington event. It is the largest geomagnetic storm in history, according to Motherboard. Based on information from FEMA, Motherboard speculates that if a storm of that magnitude hit the Earth today, GPS signals, telecommunication, and electricity would be in serious danger. On March 10th, 1989, astronomers witnessed a powerful solar flare on the surface of the sun that created a blackout in all of Quebec. This explosion released a billion-ton cloud of gas. NASA noted that this would be like the energy of 1,000 nuclear bombs exploding at the same time. So can we prepare for solar flares? Scientists cannot stop these coronal mass ejections from happening. However, if scientists learn to predict coronal mass ejections, humans can take preparative measures here on Earth. Shedding light on the origin and evolution of solar flares could help scientists forecast how powerful these explosions occur, which could help experts prevent widespread havoc on Earth, according to Space.com. Survivalist websites like Ready.gov recommend taking precautions against solar flares, just as you would for any other natural disaster. Learn to purify water and keep an emergency kit on hand with flashlights, medical supplies, and non-perishable foods.
Okay, so there's all of the information I've gathered so far. Like I said before, I would like your help gathering more information and having this discussion. And at very least, if you're not going to, if we don't open up a conversation here, I think each person watching this video would be wise to kind of look into this and do a little study of their own. And moving on now into the prepper tip of the week, I hope you enjoy. We live in the digital era, which is a time of nearly endless information gathering if you use the internet properly. All the information that the human race has is somewhere on the internet, and you can find it readily most of the time. So, during this digital era, which I project won't last much longer, don't spend your time checking your Facebook or Instagram or reading fake news stories. Instead, spend your time educating yourself and gathering resources to continue that education when the internet as a whole fails. Here I have one example, if you can ignore my sloppy handwriting, of something that I thought might be important. I started this a few years ago, so you see that the first date marked is 2016. But this is the how to tell when a leap year is going to happen, and some other things like how long exactly it takes for the Earth to rotate around the sun. As we go on, I have marked all of the dates continuing on into the year 2022, and a system for continuing that calendar from there. Well, this is just a small example of some of the stuff that I've got set aside. It's a good depiction of the things that we take for granted in our everyday life. When people aren't making and printing calendars anymore, when nobody's keeping track of the weather for you, these are some skills that you're going to have on your own. And while they may seem trivial now, they'll become very important for agriculture later. So, take advantage of the information on the internet and start taking some notes. If you don't want to go the route that I've gone, a printer can help a lot. You can just copy, paste, and print a lot of information off of the internet just to have on store when you need it the most. Okay, and there you have it. Thank you for watching. If you've made it to this point, then thanks for sitting through another one of my long rants. And that's all I got for you today. Thank you so much for watching. Please subscribe, like, and share this video around. Let's get as many people to see it as you think will help. And until my next video, see you later.